All right, today what we're going to talk about is an introduction to quadratic functions, and we're first going to focus on the parts of a parabola. So let's get started. So for your notes, it says the graph of a quadratic equation is called a parabola. Standard form of a quadratic function is f of x is equal to ax squared plus bx plus c. So of this, if a is positive, the parabola opens up, meaning it looks like that, and it has a minimum. If a is negative, the parabola opens down, which means it points downwards like that, and it has a maximum. So if you're looking here, this whole thing is called a parabola, and standard form is y, or you can put f of x, both are the same. Y f of x is ax squared plus bx plus c. The next thing are x-intercepts, and those are points on the x-axis. So remember, you write them as your x, and then your y is going to be 0. So you write wherever the x-intercepts and y is 0. So if you look on your graph here, these are the x-intercepts. And they're also called solutions, zeros, roots. Those are all different names for x-intercepts. The y-intercept is on the y-axis, and it has x is 0, and it's looking for y. So on your graph right here, you have the y-intercept. And then, let's scroll here. All right, so now we're going to kind of get into some other parts of the parabola. This is the axis of symmetry. It's a vertical line, and the equation is x equals wherever it crosses the axis. So your axis of symmetry is it's typically shown as a dashed line. And this is an imaginary line, so that's why it's dashed, on a graph which divides the parabola in half. So both sides will be mirror images, and the axis of symmetry falls exactly halfway between your x-intercepts. So I have an x-intercept here, and if you notice, we're 2 this way, 2 that way, and that's where your axis of symmetry is. The vertex point, which is xy, it's either the maximum or the minimum of the parabola. So in this case, this is the minimum of the vertex, and it would just be the ordered pair. So in this case, it'd be 1, -4. All right, domain are your x values, and for parabolas, the inequality, you're going to write -infinity to +infinity, and it has an interval of -infinity to +infinity, because as this gets wider, your x's are increasing, and then your y is also increasing, so it's positive, negative. So for parabola, these are always going to be your answers for domain. All right, now for range, this depends on the y-coordinate of the vertex. So if it opens up, you're going to write the inequality this way. So y is greater than or equal to whatever your y is for your vertex. And as an interval, if it's a closed point, which includes that point, which it should for the vertex, you're going to do a bracket, and then it's going to go to +infinity if it opens up. If it opens down, it's going to be y is less than or equal to wherever it crosses for your y, or your vertex for your y. And you'll have a parenthesis because it's coming from -infinity, and then it goes to wherever your number is. And you're going to use a bracket because it's going to include that point. All right, so now we're going to look at this one. I did this one for you, so you can go ahead and fill it out. But some important parts of this graph is when you're looking here, first off, if you notice, it opens up. So since it opens up, you have a minimum point. So your minimum point is the vertex, and that is -1, -8 right here. The axis of symmetry is wherever you would divide it in half, and it goes through the vertex. So if you look here, notice that's -1 of your vertex. It's going to be x equals -1 for your axis of symmetry. And then your x-intercepts is where it crosses. Whoops. the x-axis, so it crosses at -3, 0 and 1, 0. Your y-intercept is where it crosses the y-axis, so it's a 0, -6. Your domain is going to be -infinity to +infinity. Now your range is what we're going to look at. So notice you're going to look at, oops, I think I should have -8 there. Oh, I do need -8. I knew that didn't make sense. Because, oops. And I knew that didn't make sense because you're supposed to look at your y value for your vertex, and I realized that this was different. So that's how I figured out I made a mistake real fast. But it does include this point, so you put a bracket here, and then it goes to +infinity because it's going to continue up for the range. It's going to go all the way up. All right, so I want you to try this one, looking at the information on the graph. Now, let's say you do not have a graph and you need to find the axis of symmetry. So, to find the axis of symmetry, the formula is this, and it looks mighty similar to this formula. And if you look at the quadratic formula, it's very similar. It's just this part of the quadratic formula. So what you're going to do is we take whatever the b value is, and in this case it would be 4, and you're going to plug it in here, and then you take whatever your a value is, and you're going to multiply it here. So we don't even have to worry about the square root or any of the quadratic part. We're only worried about this part right here. Oops, sorry. That part right there. So if you were to look, you find 4, plug it in, times 2, and you would have gotten -1. Once you get this, this is your axis of symmetry. And that's also your x value and your vertex. Now once you know x is -1, substitute in that value to your original equation, and then you're going to solve for y. So let's get started with this one. Now first, label. So I did A, B, C. So I have those points labeled. And then now I'm going to do my -b over 2a. And I substituted in b here. Don't forget that negative out front, over 2 times a here. So I ended up getting x equals 2. So if you notice, that goes right there for my vertex. And then now to find your y, what we do is we take our original equation and we're going to substitute in 2 wherever you see x. And when I went through and I simplified all that, I ended up getting y is -18, which goes there. So axis of symmetry is your x, and then plug that in to find your y. All right, now there is a little trick to this one, but I'm pretty sure you can fill it out. But make sure you identify your a, b, and c, find your axis of symmetry, and then find your vertex. All right, next up is finding your x and y intercepts. So when you find your x and y intercepts, you set your quadratic equation to 0, and then you can solve using any method. So factor, quadratic formula, however you would like to solve it. And then, so that's to find your x-intercepts. And then to find the y-intercept, this one's super easy. If it's in standard form, it's whatever your c value is. So you would just put that in. If not, then you would go ahead and you would make x 0 and substitute it into the equation to find whatever y or f of x is. So let's look here. I have f of x equals 2x squared minus 8x minus 10. So to find your x-intercept, so remember, it's wherever it crosses the x-axis. So to find the x-intercept, what we're going to do is we're going to set it equal to 0, and then we're just going to factor. So I did GCF of 2, and I've got x squared minus 4x minus 5, and then you can do your x method however you want to do it, and I got x minus 5 and x plus 1. Don't forget to bring down the 2, and then set this equal to 0, this equal to 0. Well, that 2 does not equal 0, so, or you divide both sides by 2, and that cancels that out anyways. So, set this, and then you're going to end up getting x equals 5 and 1. So what you do is now you go back and plug it in to make it an ordered pair. So that's where we cross the x-axis. And again, the y value, or the y-intercept, is super easy because this is already in standard form. So all we got to do is just look here, and we know x is 0, and your y-intercept is your c-value. All right, I want you to go ahead, I want you to try this. Again, be careful with this one for your A, B, and C. And then now we're going to talk about end behavior of the graph. So we're first going to talk about, and you read this as x approaches negative infinity, y approaches what? So we're going to look here, and in this case, you're going to look for the end behavior. You're going to look at the arrows. What's happening? What direction is it going? So in this case, as x is getting more negative, y is going up. So y is going to positive infinity. And then as x is going to positive infinity, y is also going to positive infinity. All right, so if you look here, as x is going to negative infinity, isn't this the y going further down? So that should be negative infinity. And as x is approaching positive infinity, y is continuing to go down, so it would also be negative infinity. So go ahead, make sure you finish that one. And then now we're going to talk about the increasing, decreasing portion. You're looking at your x coordinate of your vertex. So think of this as a roller coaster. So this is a roller coaster. You're going this direction. So you're going to go left to right from there. And you're going to look. So go left to right. It's a roller coaster. So let's look here. And what I did is starting, think of a roller coaster. We're starting here. We're going down here, but once we hit this point, then we're going to start going up. So let's first write the vertex because that's going to help us. So your vertex is -1, -8. So the part that's increasing is a part that's going up. So in this case, it starts at -1, which is your vertex x value. And then we know that this is going up and is continuing on to infinity. And remember, since it includes a point -1, it's a bracket, and then infinity continues on, so it's a parenthesis. And then decreasing, we're coming from negative infinity, so we're coming from this, right? So we're looking at the x value, so we're coming from negative infinity, and we're going down, because this was really all the way over there, and then eventually, oh, that's horrible. So it really was really wide, and then it goes this way. So we're coming from negative infinity, and then it's going to go, and it's going to stop here, which is your x value. All right, I want you to go ahead, I want you to try that one. And then next we're going to determine if it's positive or negative. And here you're going to look at the x-axis and think of this as a submarine. So you're looking at what's above and what's below the x-axis. So as I'm looking here, you want to figure out if it's positive, it's above the x-axis. So in this case, this part and this part of your parabola is above. And then the part that's below is that part of your parabola. So when you look at this, we know that the positive portion is you've got two parts. So I said here, x is less than or equal to -3. So really you're going from here and it's any number less than or equal to 3. Or it's going from here that way. So it's on your x-axis. So one way to write it, so this is the inequality. Oops, I didn't write all the word, but you know what I was saying. Or you can do an interval. So this is your interval. All right, so for your interval, it's coming from -infinity, and then it stops here. So parentheses, bracket, and it stops at -3. Don't forget to do that symbol for union, and then it goes from here to positive infinity. Now the negative portion is whatever is below, and in this case, it's just from here to here. So that would be from -3 to 1, and you would use brackets since you're talking about both. All right, so what I want you to do is I kind of color coded for you, but if you noticed here, oops, sorry, this part and this part are below, and then this part is above. So that's your hint, so go ahead and finish here, and remember for this you're looking at the x-axis. All right, last but not least, we have a bunch of information that you need to know when you're describing a graph and the parts of the graph. So let's look at this first one. I want to know, is it a max or a minimum? Well, since it's the bottom of the parabola, it's a minimum. The vertex is at 2, -9. The axis is symmetry. Remember, it goes through the vertex. It's your x value of your vertex. And then it's also equidistant from your x-intercepts. The y-intercept is right here, 0, -5. Your x-intercepts are right here. Make sure you're looking at the axis. I've got -1, 0, 5, 0. End behavior. End behavior is where you're looking at the arrows. So this is going to continue getting larger and larger and larger. So it goes from -infinity to positive infinity. Increasing interval. Well, it increases from here up. So it's 2. So remember, you're using your x value of your vertex, and it's going to positive infinity. Your decreasing interval is here. Oops, sorry. Your decreasing interval is from -infinity to +2. So again, you notice in this case, it went right from there to there. Domain is always going to be that. Now range, it goes from -9 all the way up. So you're going to say -9, put a bracket, to positive infinity. And the positive portion is the part that is above the x-axis. So it's from here. So it's from your -infinity, and it stops here. Don't forget to make your symbol union. And then it goes from here out. So from 5, bracket, to positive infinity. And then the negative portion is all this under here, which is from -1 to 5. All right, so I want you to go ahead. I want you to put all that information on there. And then that is how you do parts, find different parts of the parabola.